All right. Okay. So this is basically a P1 past paper. And in this class, we will be talking about past paper questions only from the topics that we have discussed. Okay. Some of you were finding these topics a bit complicated, and trust me, practice is very important because students are used to doing these questions with calculators, and now when they read this thing that calculators must not be used, so then things get a bit complicated. So this is a very good chance for all of you to revise all the old contents that we have discussed. Okay, all right, so yes, all the students are complete, so let's get started. Okay, all right, so let's look at the first question. Okay, the first question says work out. Part A is 74.6 multiplied by 10 minus 3.89 multiplied by 100. Now here we have a variety of topics that we need to use. Okay, first of all, we can see we have a multiplication sign, we have a subtraction sign, we have a multiplication sign. Okay, the keyword was BODMAS. Subtraction is coming after multiplication. So first I need to multiply. I'll multiply these two numbers and I'll multiply these two numbers. Now we know whenever we are multiplying a number by 100, we just need to move the decimal. That is it. Okay. So what do we have here? 74.6 multiplied by 10. We have 10. So I'll move this decimal over here and it would become 746 minus. Now we have 3.89 multiplied by 100. So we have two zeros and this decimal would move 2 units to the right and it would become 389. Okay, next you need to find the difference in 746 and 389. Okay, and I hope that all of you know how to do subtraction. Any confusions with subtraction? Anyone? Be honest with me and you can just directly let me know if you are not. Okay, all right, and the answer is going to be 357. Okay, so I've just subtracted directly and the answer is 357. So this was a simple question where you need to understand two concepts. BODMAS, multiplication has to be done first. Number two, whenever you're multiplying a number by 100, 10, 1000, just look at the number of zeros and just move the decimal accordingly. Okay, so this was the first part. Let's talk about the second part. Again, for the second part, I need to use the same keyword, that is BODMAS. Here I have addition, I have multiplication, and I have subtraction. So multiplication comes before addition and subtraction. So first of all, I need to multiply. Okay, now I have checked your homeworks and I could see some of the students just did the working according to order. They added first and then they multiplied and then they subtracted. No, you cannot do that. In maths, we have an order for operating the operations, and the order is right here. It is BODMAS. Multiplication comes first, multiplication comes before addition and subtraction. So I will be multiplying first. Okay, so 5 would come as it is, addition would come as it is. 3 multiplied by 2 would give me, 3 multiplied by 2 is 6 minus 1. Now I have addition and I have subtraction. Now for addition and subtraction, according to the rule, it says do addition first and then subtraction. But whenever you only have addition and subtraction, just go from left to right. Okay, so we are only left with addition, subtraction. They are same. So 5 plus 6 would give you 11 minus 1 would give you 10. So the answer is going to be 10 here. Okay, any confusions? Urva, Nosharwan, Umaiza, Kabir, Taha, Muiz?
No, ma'am.
Okay, all right. And I want all of you to be honest because, this is the time when you need to tell me if you are not able to understand anything. Okay, anyways. Okay, let's talk about the second question now. All right, now it's interesting. Okay. Question number 2, you have a variety of numbers 15, 125, root 8, 11, root 25, 14, 60. From the numbers above, write down a factor of 70. Okay, write down a factor of 70. Now, one thing should be clear when we're talking about the factors of 70, obviously it cannot be anything greater than 70. So 125 cannot be the choice. Okay, think about 15. Is 15 a factor of 70? Can you divide 70 by 15? No, 15 multiplied by 4 is 60 and 15 multiplied by 5 is 75. Okay, so 15 cannot be the number. Root 8 cannot be the number. 11 is not there in the table. It cannot be, 70 is not there in the table of 11. Okay, then root 25 would give you plus minus 5, and then we have 14, and then we have 60. Okay, so if we are to pick a number that is a factor of 70, the number is going to be 14. You're right, Umayza, very good. You're right, the number is going to be 14, and you can just write down the answer. It is 14. Okay, that is correct. Very good. Excellent. Okay. Now some of you can also say that root 25 is 5, so that could also be a factor, and I would agree. You can also write down root 25, but you will see that root 25 would be used somewhere in the future as well. Okay, like in the coming question. So 14 is the safest option. Okay, just always go for safest options. Okay, because you have root 25. They did not say 5. Okay, so root 25 would be used somewhere else as well. You'll see that. All right. Okay. So we are done with the first part of the question. Very good. The second one, which is a cube number? Okay. Now, what is a cube number? A cube number is basically a number that when you do its prime factorization, all the factors are coming with cubic powers. Okay. Okay. If I do prime factorization of 15, I would just get 3 multiplied by 5. If I do the prime factorization of 125, I would get 5 multiplied by 5 multiplied by 5, and this is 5 cubed. So there's no point in checking the other numbers. 5 multiplied by 5 multiplied by 5 would give you 5 cubed. So it means that 125 is basically 5 cubed, and this certainly is a cube number. So I can write down 125 here. Okay, and then the last one says an irrational number. Okay, so a rational number is basically a number which you can write down as a fraction. For example, 1 by 3 is a fraction. For example, 15 by 2. For example, 8 by 9. All these are rational numbers because you can write those numbers as fraction. Let's say if we talk about 3.5, I can also write down 3.5 as a fraction. How? 3.5 can be written as 35 by 10. In short, this is what a rational number is. Okay, the question is about irrational numbers. So we have a big set of numbers coming under irrational numbers. So I'll just give you a hint. I'll give you a technique, and using this technique every time you'll get the answer right. So if the examiner wants you to write down an irrational number, always look for such numbers. Okay, always look for such numbers. Now it is root 8. I know that 8 is not a perfect square, so this is basically called a surd. However, root 25 would give me plus minus 5. So for surds, every surd is considered to be an irrational number. Okay, 15 is rational, 125 is rational, 11 is rational, this is rational, this is rational, this is rational. All these numbers are rational. If a number is not rational, then it is irrational. So forget about everything and just listen to me now. If you have been asked to find out the irrational number, look for surds. What is a surd? Surd is a number that is coming this way. Root 3 is a surd. Root 10 is a surd. Root 100 is not a surd because root 100 is giving you 10. Okay, so if you have an imperfect square inside square root, then that is basically a surd. So 8 is not a perfect square, root 8 is a surd. So the answer is going to be root 8 here. Are we clear with these three things? Please tell me honestly if you have understood this or not.
Yes. Yeah.
Sorry, I was not able to understand. 1 second. Say it again.
Yeah.
Okay. All right. Okay. Let me explain the third part. One student wants me to explain it again. I'll explain. I can understand. For irrational numbers, we look for surds. How do we define a surd? A surd is basically a number that comes under root. Okay, surd is a number that comes under root. So this is a root, and I have two options here. I have root 8 and I have root 25. So it is a number that comes under root, and the number is not a perfect square. I know that 25 is a perfect square. Why is 25 a perfect square? Because 5 multiplied by 5 gives me 25. The answer of root 25 is 5. But if I am to tell the answer of root 8, I'm not sure, because 8 is not a perfect square. So whenever you have under root, and inside that under root you have a number that is not a perfect square, that is going to be irrational. Yes, well done, Umayza. Excellent. Yes, this is the definition. Okay, very good. Well done. Perfect. Okay, so yes, this was the idea about it, and these things, such questions would get better with practice. Okay, such questions would get, definitely they would get better with practice. Okay, let's talk about the third question. And obviously, if you have any confusion in any of the previous parts, just leave that confusion over there, because the next question is not related to the previous one. Just stay in present, and if you have any queries, just note it down that you were not able to understand question 2 part this. You can message me directly, or at the end I'll ask you again, and then you can just let me know if you were not able to understand anything. Okay, acha. Now this is the most important question I wanted to talk about. Question 3 part A. You have two fractions, and between these two fractions you have addition sign. Now some of the students, what they did, they just converted the fractions to decimal numbers and then they added. So you are not supposed to do these questions this way. If you have fractions, deal with them as a fraction. Do not convert a fraction to a decimal until and unless the examiner wants you to do that. Okay, I have explained that concept, that how do we go from a fraction to a decimal, but not for this question. I taught that for questions where you need to arrange numbers in order, and for questions where the examiner would want you to do that, but not for these questions. Okay, so just listen to me carefully. Whenever you have two fractions with a plus or minus sign between them, okay, with a plus or minus sign between them, this is what we do. What do? We have a plus here. Plus means, minus means I need to take the LCM. I have plus, I'll be taking the LCM. The LCM of 7 and 5. Okay, so here is 7 and here is 5. So I'll write down 5 first. This would come as it is. I would write down 1, then 7, 1 and 1. And the LCM of 7 and 5 has turned out to be 35. Okay, it's 35. Now, how do we do it? The LCM is 35. I need to multiply 5 with 7 in order to get the LCM, that is 35. So if I will multiply 5 with 7, I'll do that in the numerator as well, because in maths we need to balance everything. And this 5 has to be multiplied with 7 in order to get 35. So if I am multiplying the denominator with 7, I need to multiply the numerator with 7 as well. It's very easy. Okay. Yes, very good, Muiz. It's easy. We had 7 and 5 as denominators for two fractions which had a plus between them. For plus and minus, we take the LCM. We're done with the LCM. Now I need to multiply 7 with 5 in order to get 35. If I'm multiplying 7 with 5, I will be multiplying 3 with 5 as well. And if I'm multiplying this 5 with 7, I will be multiplying this 2 with 7 as well. Okay. Now 3 multiplied by 5 would give me 15. And 2 multiplied by 7 would give me 14. Now 15 plus 14 would give me 29 divided by 35, and this is going to be the answer. Okay, I know for some of you this question is easy, but I'm just explaining this for some other students, and it's completely fine. Okay, this is the time when we need to discuss and address all the queries, because we have a lot of time at this point. So it's 29 divided by 35, and this is going to be the answer. So please always remember, for plus and minus, for two fractions, You will not be converting the numbers to decimal. No, you will be taking the LCM and then we will simplify this. Okay. Yes, Urva, Nosharwan, Kabir, Umaiza. Understood?
Yes, ma'am.
Yes, ma'am.
Okay. All right. Okay. So I hope that this part is clear. All right. Okay. Let me just zoom out. Okay, let's talk about the second part of the third question. Find 2 by 3 of 6 by 11, giving your answer as a fraction in its simplest form. Okay. Now the wording says find 2 by 3 of 6 by 11. What does it even mean? I'm not sure. So we have some English words in maths. Of means multiply. Is means equal to. Okay. So it's 2 by 3. Of means multiply 6 by 11. So when the examiner says 2 by 3 of 6 by 11, it means 2 by 3 multiplied by 6 by 11, because of means multiplication. Okay, of is multiplication. So this is what it is. Acha, you need to give your final answer as a fraction in its simplest form. So we won't be converting this to decimal, not at all. When the examiner is giving you fractions, deal with them as a fraction. Okay, for simplest form, I need to cancel out things. So it's 1 times and it's 2 times. So this would give me 3 multiplied by 1 is 3 and 3 multiplied by 2 is 6. Okay, this is why I got 2 here. So 2 multiplied by 2 would give me 4 and 4 divided by 11, and this is going to be the answer. So a fraction in its simplest form basically means that you need to cancel out. You need to cancel out as much as possible. Okay, some of you would have said that the why isn't the answer 12 by 33? 12 by 33 is also correct, but you won't get 1 mark because the examiner clearly says you need to give the answer in simplest form. So this means just cancel out everything and then give the answer. Okay. Let's talk about the sixth question now. All right. Now, some quick revision of what we discussed in the very early classes. Okay. Question number 6, part A says, write 308 as a product of its prime factors. Okay. So it's prime factorization. It's 308. So the first number that would come to my mind is a 2. Okay, now when I will divide 308 by 2, what would I get? Yes, it would be 154, right? It is going to give you 154. Then again, I have a 4 at the end. 4 is an even number. It means this number would be divisible by 2. So again 2. Let's this time, let me just explain the long division as well. It's 2. So I would be writing down 7. And that would give 2 multiplied by 7 is 14, and I would have a 1 as the difference. And then I'll just take this 4 down. Again, it's 7, 14, and 0. It's 77. Okay, now the next number is going to be, it cannot be 2, it cannot be 3, it cannot be 5, it would be 7. And then 7 multiplied by 11 gives me 77, and then it would be 11. Okay, so 308 as a product of its prime factors would be 2 squared multiplied by 7 multiplied by 11. So it would give you 2 squared multiplied by 7 multiplied by 11. Okay, this is going to be your prime factorization. It was easy, right? We just need to write down the prime factors and we will just write them down this way. Any confusions with this? Okay. All right. So I hope this part is clear. Okay, well done. Acha. The next part of the question says, find the highest common factor of 308 and 66. Okay. I'll be doing this question to using 2 methods. Trust me, I've seen students, they are excellent at difficult topics and they just don't get these basic things. Okay. I've noticed this thing quite a lot of times. That is why I'm, emphasizing on this. Let's talk about method number 1. Okay. So I'll be doing it this way. It's 308 and it's 66. So the first number is 2. I would get 154 and I would get 33. Okay. The next number or the second number is going to be, yes,
Is it 3?
we can use both because we can see that 154 is divisible by 2 and 33 is divisible by 3. Okay. So this is going to give me, I'll write a 2 here and it would give me again 77. And this 33 would come as it is. And again, I can take 3 this time around. It would give me 77 and 11. And now 11 for both of them. So it's 7 and 1 and then 7. It would give me 1 and 1. Okay. All right. Now this is method 1. One sec. Let me just scroll up a bit. This is method 1 for finding the HCF. Okay. But one second, I need to let Kabir in. All right, okay. Now this is method 1. And method 1 basically says that you'll be writing down both the numbers and you'll just, do it this way. And then we will multiply the two numbers and then we will see, okay? But for this combination, this is not going to work. Why? You'll see that. Just hold on for some time. Let's talk about method 2. And then again, I'll get back to method 1. Method number 2. Method number 2 says, write down the prime factorization of both the numbers. Okay. So if I write down the prime factorizations of both the numbers, 308 is 2 squared multiplied by 7 multiplied by 11. This is what we did in the previous part. And for 66, I'll quickly just do that over here. It's 66, it's 2 times, it's 33, it's 3, it's 11 and 11 and 1 and 1. So 66 can be written as 2 multiplied by 3 multiplied by 11. Okay. Just method 2. Focus on method 2. I did not explain method 1 because this time around method 1 is not going to work and I'll tell you the reason later on. But first let's focus on method 2. Okay, now again the idea is about finding the highest common factor. Okay, what do we do in highest common factors? In highest common factors, you are just supposed to write down the numbers that are coming common and just multiply them. So instead of writing it this way, I'll just write 2 twice. All right, this is 308 and this is its prime factorization, 2 multiplied by 2 multiplied by 7 multiplied by 11. This is 66 and I've just explained the prime factorization of 66 and that gave me 2 multiplied by 3 multiplied by 11. Okay, how do we take the HCF? I need to encircle the common numbers. I need to write down the common numbers once only. 2 multiplied by 11 and this would give you 22 and 22 is going to be the highest common factor. So for HCF, you write down the prime factorizations and after writing down the prime factorizations, you are just going to pick up the common numbers and multiply them. We don't do anything with these numbers in case of HCF. Yes, when we do LCM, there the method is different. There I also use these underlying numbers, but for HCF, only the common numbers. Just write them down once and multiply them and it would give you the answer. Okay. Sorry, 1 second. Say it now.
Yes, ma'am, understood.
Okay, all right. Now this was method number 2. If I talk about method 1, I'll tell you what happened and where we went wrong. Okay. This is certainly correct. This is certainly correct. And this is how we do the LCM. Like we just multiply all these numbers and this gives you LCM. But for HCF, things are different. Okay. For HCF, I'll tell you what went wrong. For HCF, through method 2, you have seen we are only interested in the common numbers. We are only interested in the common numbers. When I say that we are only interested in the common numbers for method 1, again, we will be interested in common numbers only. So when I'll divide it by 2, it would give me 154 and 33. Now 2 is not a common factor. 3 is not a common factor. 5 is not there for both of them. Okay. Then 7 is not a common factor. Then we have 11. Yes, 11 is your common factor. Okay. This is where we went wrong. The method we applied initially is how we do in LCM. But for HCF, always remember we are looking for the common factors only. Very good. For 11, we do not study the divisibility rule. We just do it till 10. But for 11, you know, it's basically 11, then it's 22, it's 33, it's 44, that's 121. But for 154, we'll have to check that. Okay, you'll have to check that. This is 11 and it would give you 14 multiplied by 11 gives you 154. And this is 3. And now, do we have any other prime factor that is a common factor for both of them? Is it 2? No. Is it 3? No. So that is it. You need to stop here. You need to stop here. Okay. And we will just multiply these two numbers and it would give you 2 multiplied by 11. That is 22. This is how things are for HCF. For LCM, what do? We multiply these numbers. We just make an L and we multiply these numbers and this would give you the correct answer. Or you can just, you know, complete the numbers until you get 1 here, you can just multiply those numbers. But the way I do it every time is just this. Just do it like this. And then for HCF, just multiply these two numbers, and for LCM, just make this type of L and multiply these 4 numbers. Okay. But for now, forget about LCM. We are not discussing LCM. We're discussing HCF. We know how to find HCF now. We have 2 methods. Method 1 is by just writing down the common factors and then, you know, multiplying them. And once you are not able to find anything in common, you need to just stop and just multiply the numbers. And method 2 is just writing down the prime factorizations of both the numbers, picking up the common ones, and then you multiply them. Okay. Now tell me honestly if you have anything that is coming to your mind.
No confusion.
Okay, Kabir, Nosharwan, Umaiza,
Yes,
and Urva.
ma'am, no confusion.
Okay, Nosharwan, understood?
Yes.
All right. Okay. So Urva and Umaiza, please confirm.
Yes, ma'am. Understood.
Okay. So if all of you are saying understood, that I hope that it's actually understood, because I personally think this topic is confusing. Okay. Anyways, if you guys are confident, then that's good. Let's talk about another exam and some more questions. Okay. All right. So it is. Here it is. Okay. Question number 1, part A. Write 0.45 as a fraction in its lowest terms. Okay. It is a decimal number. How do we convert a decimal number to fraction? 0.45 can be written as 45 divided by how many decimal places do we have? We have 2 decimal places. So I'll divide 45 by 100. Very good, Umaiza. We will divide 45 by 100. And when it says fraction in its lowest terms, it means I need to just cancel out things. Okay, so I can see 5 is a common factor for both of them. 5 multiplied by 9 is 45 and 5 multiplied by 20 is 100. Very good, Umaiza. So it would give you 9 divided by 20, and this is going to be the answer. So if you have a decimal number and if you're interested in converting it to a fraction, just look at the number of decimal places. We have 2 decimal places for 0.45. Just write down that number without decimal and divide it by 10, 100,000, depending upon how many decimal places you had. And then we just cancel out the numerator and denominator, and we got 9 by 20. Okay. Can you guys try doing the second part of this question? Write these fractions in order, starting with the smallest. I'll give you a hint. We have fractions. So we have two methods. You have two methods here. Either you can convert all these numbers to decimal, which would take good amount of time, then do it, or you can just use the LCM method. Okay. I'll wait, think about it for 2 minutes, and then I'll tell you how to do it. But please be quick. And do not wait for me. Just try doing it all by yourselves as well, and then we'll discuss it together. Okay, so for this question, we have two methods. Let's stick to one method for now, and that is converting these numbers to decimals. We have 4 by 5. It's 4 and it's 5. I need decimal. It's 40 and it's 8. It would give me 0. So 4 by 5 is 0.8. What about 7 by 10? Now 7 by 10 is easy. I have 10 in the denominator, so I can write it down directly. There's no point in wasting your time and converting it to decimal. 7 by 10 means I can just move this decimal 1 unit to the left. So it would become 0.7, okay? And the last one is 17 by 20. It's 17 and it's 20, so I need a decimal. And this would give me 170. So 20 multiplied by 7 is 140, and then 20 multiplied by 8 is 160. Again, it would give me 10, and I'll write down 0, and it's going to be 5. So 17 divided by 20 is going to be 0.85. Now we can easily see which number is smallest. 0.7 is smallest, so I'll write down 7 by 10. Then 0.8 is the next one, so I'll write down 4 by 5. Then it's 0.85, so I'll write down 17 by 20. This is going to be your answer. Okay. So again, we had fractions. We don't know how to interpret fractions directly. I converted these fractions to decimals by doing long division. And for the final answer, I need to write down the fractions. Okay. So this was the second part of the first question. Okay. All right. Let's talk about the fourth question. Okay. It says write this number correct to the nearest million. Okay. So for that, you need to understand this is units, tens, hundreds, thousand. One second. Okay. This one is 10,000. One second, please. Okay. It's units, it's tens, hundreds, thousands. Then we have 10,000. Then we have 100,000 or lakhs. It's your choice, whatever way you were used to writing it down. 100,000. And then we have millions. Okay, so I'll just write it down as lakhs. Okay, so yes, very good. Taha, your answer is technically correct, but let's discuss it. Okay, so this is how it is. We have units, we have tens, we have hundreds, we have thousands, we have 10,000s, and we have lakhs, we have millions, and so on. And then we have crores, and this is how it is. The question says, write it down to the nearest million. Okay. So to the nearest million basically means that I need to look at this one. So the questions we discussed in class were basically of this type, that write on the number correct to one significant figure, two significant figures. This time around it says nearest million. So we need to just write it down till the second digit. Okay, so 6 would come as it is. After the second digit, the third one is 7. 7 is greater than 5, so it would become 6, 5, and then we have 0, 0, 0, 0, 0, 0. So in million, in 1 million, we have 6 zeros. So this is 65 million. Okay. So this is going to be the answer. 65000, and then we have again 0, 0, 0. So this is how it is. Okay. All right. So any confusions with this? Okay. 1 second. Yes, I agree. This is confusing. I'll tell you why. Because this was the question type we discussed in class, right? In the questions which we discussed after covering the rounding off chapter, basically had such wordings: round it off to one significant figure, to two significant figure. But this is completely fine. If the examiner is saying to the nearest million, you just need to understand the units. The first one is units, then it's tens, it's hundred, it's thousand, it's 10,000, it's lakhs, it's millions. And that is how it is. So the second one is basically for millions. When it says to the nearest millions, I need to write down 2 digits only. Okay. So for 2 digits, 4 is the digit I need to focus on. It would either remain 4 or it would become 5. The number next to 4 is 5. The number next to 4 is 7. It's greater than 5. So 4 would become 5. And this is going to be the answer. Yes. Any confusions?
No, ma'am.
Okay, all right, that's perfect. So let me just stop the recording.